Now, if you start to struggle with these definitions, I want you to go back to this section so you can see that these definitions work. It's easier to understand in a single period model. Now, as we get into more complex models, you have to believe that these definitions work. We could use a lot of different examples to illustrate the multi-period framework. I'm just using this as an opportunity to teach the bond concept. So we're going to use a bond example. A bond is generally a security that promises a fixed periodic payment. A bond is basically a debt. An example, consider a bond with a par value of $1,000. It pays a coupon of 8% annually, and the coupon is paid semi-annual at 8%. It matures in 10 years. It may have been issued 20 years ago, may have been a 30-year bond, but at this point in time we're assuming that there are 10 years left on it with semi-annual payments paid at 8% annually. Okay, the holder of the bond is going to receive its par value of $1,000 at maturity. In addition to that, there's going to be a coupon paid at 8% paid semi-annually. It's called coupon because way back in the old days when the holders of these bonds would actually clip the coupon and send it in to get their money. Not so true anymore, but that language is still carried over, so they still call it coupon rates. It's interest. To calculate the coupon, we take the 8% of the par value. So that par value serves two purposes. One is the face value of that bond. To calculate the coupon, we multiply the coupon rate times that par value. And in addition, when that bond matures, then whoever holds that bond at that moment receives the face value of that bond, which is the par value of the bond. Back to the coupon, 8% of 1,000 is $80. But we said, by looking at this S at the 8, represents that it's going to be paid semi-annual. If we get that $800 paid divided over 1 year, we take the 80 and divide it by 2, so we're going to get a $40 every 6 months. It's still 40 plus 40 is still the $80, but we get it quicker. And you know now that you understand the time value of money, that's a good thing if you're receiving the coupon. You want it as quick as you can get it. Now, if we look at the cash flow of this bond, we draw our line. Notice that we're starting today, and we're going to go, it's 10 years, but because it's paid semi-annual, we multiply the years by 2. There are 20 periods, 26-month periods. So you're going from the first 6-month period to the second all the way to 20. And notice that we're going to receive a $40 coupon at the end of each of those 20 periods. Also notice that they're end of period. Also notice that at the end of that 10 years or 26-month periods, we're also going to receive the face value or par value of that bond, and not until then. And by the way, this is a standard bond example. If you go to the Wall Street, this is exactly what you're reading if you're talking about bonds. The face value may be different, the coupon rate may be different, but most of them actually do semi-annual. First problem. Again, remember that these problems are all in your handouts. I'm just working through homework type of problems that are in that packet in front of you. This is the problem part A of the bond example. And we want to calculate the book value of the bond. If we look at this, we draw the line in the timeline, and it's the same timeline that was on the previous slide. But in this particular case, we want to know the book value. We're going to calculate the book value. And what was the definition of the book value? It was the present value of all these remaining payments discounted at the contractual rate. Here we have to be careful because the contractual rate was 8S, which means we have to take that annual rate and divide it by 2. It's divided by 2 because it's semi-annual payment. Okay? So in this particular case, notice that we have a uniform series. If we want to find the present value of a uniform series, we're going to use the uniform series present value factor at the contractual rate for 20 periods. We also have a $1,000 face value that we receive at the end of 10 years. So notice that we have a $1,000 single sum of money. Notice that we're going to discount it back using the present value of a single sum of money. Thus, we're mixing the factors. Again, we do it with the semi-annual rate of 4%, and we discount it back 20 periods, because that's what we show on the timeline, and we're discounting it back 20 periods. Okay, if we look at this, we put 20 in, a 4% I, a $40 payment, and a $1,000 future value. Now you can put the 40 as negative and the 1,000 as negative. That's okay. And you'll get a positive answer when you do the present value. Or you can put them in as the two positive or the two negative, but don't mix them, because these are both cash inflows. And the answer comes up to be $1,000. Unless you're doing funny things with the bonds, that will always be the case. The book value will always be equal to the face value. Just by definition, the way that's calculated, you can see that that has to be true. First, just so you can see how to calculate book value using Excel, we basically are using this formula. We can put equals PV. We put the rate of 4%. The number of periods is 20. The payment is negative 40. And the future value is a negative 1,000. We plug that in to our Excel sheet, and we get 1,000. You can check that out on Excel. It's just like punching the numbers into your calculator. And again, I encourage you to do this on Excel so you're comfortable with doing these type of problems on the computer. Okay, the next problem, let's calculate the market value or the price of the bond if the market rate or its yield is 12%. Again, the timeline looks the same, but notice in this case we are looking for the market value. And the definition of market value is the present value of the remaining payments discounted at the market rate. In this case, we take the market rate of 12%, which is annual, and divide it by 2 because this is a semi-annual rate, and we get a semi-annual rate of 6%. To find the market value, then, again, we take the present value of this $40 annuity at 6% for 20 periods, and then we take the $1,000 single sum of money and discount it back using the present value of a single sum factor at 6% for 20 periods. Then you can use your calculator and put 20 in, 6% I, $40 payment, $1,000 future value, compute the present value, and it comes out to $770.60. What does that mean? It means that if you had an opportunity to invest your money at 12% annual, compounded semi-annually, and you had an opportunity to buy this bond that had these cash flows associated with it, in order for you to earn this 12% annually, how much would you pay for that bond? $770. If you paid less for that bond, what would that do to your rate of return? You'd like that, right? If you had to pay more, then it would give you a lower rate of return. So if you got opportunities to invest your money at 12%, you are not going to pay more than $770, are you? And nobody's going to sell you that bond for less than $770. So what's the price? $770. That's how the market determines the price of bonds. Now, if the market rate changes, what happens to the price? It's going to change also, isn't it? Now, to calculate this with Excel, it's the same thing as the book value, but equals the present value, and then you open paren, put the rate of 6%, 20 periods, $40 payment, $1,000 future value, and sure enough, if you put that in Excel, it's going to give you $770.60. Now, looking at the relationship between the price of the bond and the interest rate, notice that as interest rates go up, people are going to pay less for the bond. If you look at it from a single period model again, if you look at the price of an investment is divided by its returns minus the interest rate. Remember that equation? You know, you can flip that. You can say the interest rate is equal to what? The returns divided by price. If you look at this, what happens when the interest rate goes up? What happens to price in this equation? Okay, the price is going to go down. And we see this in a multi-period framework as well. As the interest rate goes up, you're seeing the price go down. This relationship, if you're in personal finance and you're looking to invest in the bond market, let's say that the interest rates are low now they're at 4%. And you are sure that because of Hurricane Katrina and the war in Iraq, then you're just sure that interest rates are going to go up in the next 2 years. Is this the time to buy bonds? If you buy bonds right here, 2 years from now, what happens to your price of your bond? You paid $1,400 for this bond. How much is it worth now in 2 years? $1,000. How much did you lose? So you thought you were getting 4%, didn't you? If you sell those bonds at that price in 2 years, do you still make 4%? You've lost a lot of money, haven't you? You're talking about a minus $400 divided by the $1,400 that you put into it. You're talking about a major loss. On the other hand, if the bonds are at 7%, and you think that because of frugal policy and because of the expansion of the economy or whatever, or decline of the economy or however, you think that interest rates are going to go down, is it a good idea to purchase bonds? Because here you're paying $1,000 for it, and in a couple of years you're getting $1,400. You've made $400 plus whatever interest that you've made on it, right? So now you'd say it's a good investment. Now, if you're coming to school in your car and you're listening to the radio, and the radio announcer says that the price of bonds has gone up, what does that imply about interest rates? They've gone down. And often they refer to that. The bonds have gone up. That implies that interest rates have gone down. You've got that inverse relationship.